beings were not there, life was very limited in time. And then something happened, the ice melted and we had a completely ice-free Earth. So we have oscillated between ice-free Earth and ice-covered Earth for a long period. Okay? And most of this period, of course, there was hardly any, big life. There were bacteria and viruses and so on, but not human beings and mammals. Okay. So the point is, you have to understand why this fluctuation occurred. Because if you want to predict future, you better understand, because see, last 10,000 years we were lucky, climate is stable, but that is not the normal state of the Earth's climate. So you have to know that Earth can suddenly switch to a very cold climate, a very warm climate, if you do any perturbation to the Earth system. Okay. Next slide shows what are the proxies used for inferring climate. I will not go into detail. Any of you is interested today, all you have to do is go to Wikipedia, open a page on proxies, they'll give you all the information. So this shows from sediments in the ocean, which are sensitive to temperature, lake sediments, ice cores, I'll talk about tree rings, of course, all of you know. Growth of the tree depends on temperature. So of course historical data. All these have been used to infer the change of climate over the past 10 million years. Okay? Remember, these are not very accurate. One cannot be sure about within 0.5 degree or something, but gives you a clear idea of whether it was an ice age or it was a warm climate. Okay. Next slide tells you the most interesting thing done in the last 50 years. A group of scientists from various countries went to a place in Antarctica called Vostok. There is a lake there, deep inside. And on top of the lake there is 4 kilometer thick ice. Okay. And so they drilled right through that, like our people drill bore wells every day. So they drilled all the way down and they took the ice core. Next slide. This is the ice core which comes out from the drilling, and that ice contains the history of the Earth. Okay. So if you look at the last 1,000 years, we can look at the written record of our history and you can see what our ancestors wrote about. But you want to go back 10 million years, there is no written history. The history is written in the rocks and in the ice and in the sediments. And you have to be smart enough to interpret it. That is the ingenuity of human beings. So this ice core contains information about what kind of atmosphere was there at that time. I'm talking about 10,000, 20,000 million years ago. And what was the temperature. Okay, next slide. From that, now you can, this ice core contains air bubbles. Because remember, when the snow falls in Antarctic and Arctic, it gets compressed, and small bubbles of air get trapped and they get sealed beautifully. Okay. So all they have done is taken that ice core out, gone to the lab, very carefully put a hypodermic needle and sucked the air out and looked at its composition. Now this is very, very intricate work. I'm really impressed how well they do it. So they compare the composition of the Earth 20,000 years ago or even million years ago compared to today. Okay. That's one part, that is the composition. Second part is they take the ice itself and look at the isotope of oxygen 18 and 16. All of you know oxygen has many isotopes, the heavy isotope and the light isotope. They look at the ratio and one can show that the ratio of the heavier isotope 18 to lighter isotope is a measure of temperature. Now I won't be able to have time to tell you why. Again, go look at, do a Google search, it will give you a nice article telling you how isotope ratios are related to temperature. Okay. Next slide. So this slide, go back, Yeah, so this slide from Vostok looks at the last 400,000 years of Earth's climate, and from the isotope ratio, they figured out that Earth had 4 major ice ages, 1, 2, 3, 4. Okay? The last one was 20,000 years ago, okay, which we saw in the other slide. So there are 4 major ice ages in 400,000. Every 100,000 years we had an ice age. Okay. Now this repeats very cyclically, and occasionally we have some warm climate, very short climate, warm climate, and we human beings of course need a warm climate. So human beings didn't grow in size until the last period here. This is where human beings really population went up. Before that, there were human beings in caves mostly, hunter-gatherers, not agriculture. Okay. Okay. So this was the first evidence that came about 30, 40 years ago, which showed that Earth's climate is not stable, it fluctuates on various time scales, and 100,000 is the dominant time scale. Okay, next slide. Now, so essentially what happened was, before human beings came on in a big way, Earth was mostly in a glacial age, and suddenly it went into a warm period called interglacial, stayed there for some time, then came back. It fluctuated in these two, okay? And the question we want to ask is, what triggers the Earth to move from this state to that state? Okay? It's very important because today we human beings may be perturbing the Earth's climate so that it can move from this state to some other state. Okay? So in 2015 there was an agreement, all the countries came to an agreement that we must reduce the release of carbon dioxide through our action in order not to let the temperature of the Earth go 2 degrees above the temperature in 1850. Okay? Now why did they decide that? Because they felt that the temperature goes beyond 2 or beyond 1.5 according to some people, the Earth may start moving to much warmer state, which is not good for us. Okay? So that was a concern. Okay, let's say next what. Okay, so go back. Yeah. Now to understand the global mean temperature, it's a very simple energy balance. All of you know that the laws of physics dictate that energy must be conserved. Okay? And so that is the principle you want to use to understand the global mean temperature. And so the absorption of radiation by the Earth and atmosphere has to equal to emission by the Earth to space. This is the balance. Okay? Now let's look at the balance. Next slide. What controls the balance? If you look at the emission, the Earth emission of radiation, it occurs in a region we cannot see. It's in the infrared. So everything here is emitting radiation. All the walls, you can't see it, but you can feel it. It feels hot already. Okay. So that radiation is trapped by 4 minor gases: carbon dioxide, water vapor, methane, oxygen. Now this was not known 100 years back. People thought nitrogen, oxygen, argon constitute 99.9% of the Earth's atmosphere, and they are totally transparent. They neither absorb sun radiation nor the Earth radiation. So Fourier, a well-known scientist in France, wondered if none of the gas atmosphere absorb Earth radiation, the Earth should have been much colder. You can calculate very easily how much radiation is reflected by the Earth. So whatever is absorbed has to be emitted back to space. One can do a simple work based on physics 100 years ago and realize that something is not right. So Fourier argued 200 years ago that gases like carbon dioxide, methane, water vapor must be trapping the Earth radiation. But at that time we didn't have good data. Today we have extremely high resolution data of the absorption spectrum of carbon dioxide, methane, water vapor and ozone. We know all of them absorb radiation in the region where Earth emits radiation. And that is called the greenhouse effect. Okay? So that's one thing that's keeping Earth warm. And what's the value? You can calculate that by looking at how much radiation is emitted to space from the surface. Okay? And how much is emitted to the surface minus how much is leaving to the space. This is measured by satellite, this is measured from the surface. This difference today is 150 watts a meter square. That 150 watts a meter square is what kept the Earth warm, okay, and at 50 degrees centigrade. But now what's happening is human beings are adding more carbon dioxide, and so that's increasing temperature by 1 degree centigrade. Along with water vapor, you will see that. Water vapor also plays a role. Okay? Now I want you to compare what happens on Earth and Venus. Venus is considered Earth's twin. Okay? Similar size, similar to the Sun, but composition is a little different and a little closer to the Sun. The surface temperature of Venus is 720 degrees Kelvin. So nobody can live there. It's hell. Nobody can live there. And ironically, Venus is covered with clouds. At night you go and watch Venus, it looks cloud covered. So many people thought, since it's cloud covered, it must be cool because cloud reflects radiation. But unfortunately on Venus, the amount of carbon dioxide there is million times more than on Earth. Million times, okay, remember that. Because of that, the greenhouse effect is 100 times larger. Okay? So what we should be worried about is Venus and Earth have similar radius, similar structure. So if the human beings do something silly like adding more CO2, it's not impossible that one day it may not happen now, it may happen after a billion years, but that's possible because we have similar size and so on. Okay, next slide. Now, which are the gases causing absorption of Earth's radiation? The most important is water vapor. 60% of the radiation that is absorbed is by water vapor, about 100 watts per meter square. Then next is carbon dioxide, then ozone, then methane and so on. Now let me ask a question. If water vapor is so important in controlling Earth's climate, you don't find that word in the Paris Agreement. The Paris Agreement is there only for limiting the release of CO2. Nobody talks about limiting water vapor. Why? Anybody can guess why water vapor is not being controlled by law? Can't hear you, loud. Noise of the fan. Can you?
That means that the water bodies on Earth could be evaporated.
No. Can we make a law to control water vapor on Earth? That's what I'm asking. Can we make a law to control water vapor on Earth or not? Yeah.
Because the evaporation is a surface phenomenon, sir. So we cannot control the evaporation and we cannot control the water.
Why not? Why can't you control evaporation? Tell me.
Because it is a surface phenomenon and evaporation may occur anytime in the due to heat energy.
Okay, it's a good point, but let me give you a little hint, little variation. You know that in many dams that we have built in the world, there is water behind the dam, okay, which is used for hydropower irrigation. Now, during the period between October to May, a lot of water evaporates. You know what they try to do? They cover it with ethyl alcohol or some other layer of what you call monomer, which will prevent evaporation. You can do this. You can control evaporation. It's not impossible. Okay, but you are right. Evaporation is. But there is much more fundamental law in physics which says you cannot control Earth's temperature. You cannot control water vapor on Earth. How many of you heard of the famous law called Claption equation? Anybody? Has it been taught to you? It's a famous law called Claption equation, which relates the water vapor pressure in the atmosphere, saturation, with temperature. Okay, all of you heard about it, right? So that law dictates that as the temperature goes up due to increase in CO2, water vapor will automatically go up. You cannot do anything. Okay. Why is that? Because in the Earth's atmosphere, water vapor can condense. For example, those of you who have a two-wheeler, at the exhaust you see water vapor condensing, right? So on Earth, water vapor can condense, become ice, become liquid water. CO2 cannot condense. CO2 condense is very low. So carbon dioxide, which is releasing the atmosphere, goes on accumulating. Water vapor among the atmosphere is not determined by how much we are releasing, but by temperature. So what's happening here is, we are releasing carbon dioxide, it doesn't go away anywhere except remains in the atmosphere. Some of it goes into the ocean, some goes into land. Whatever is remaining is increasing and trapping more heat, and once the temperature goes up, water vapor automatically goes up. We have no control over it. So no Paris Agreement can control water vapor because what you call concentration is controlled by temperature, which is controlled by CO2. Okay, next slide. Same thing as in words here in case any of you didn't follow me. So water vapor is an amplifier. It is not the cause, it is the amplifier. Cause is CO2. And then whatever joins in the process is like a what you may call chain reaction. First CO2 goes up, temperature goes up, whatever immediately goes up. Okay, that's how it is. Okay, next slide. Now we come to the role of Earth. Earth reflects a lot of radiation into space. How much it reflects depends on how much ice we have and how much water we have. Okay, it is the ocean. You see clearly the difference between ice and ocean. Ice reflects 90% of the sun's radiation, while ocean only reflects 10%. So the difference of 9 times. So when ice melts, you are going to increase the amount of radiation absorbed roughly 9 times or roughly 10 times. Okay? So that is the danger, that as ice starts melting, it's already melting all over in the Himalayas, in the Arctic and the Antarctic. As ice melts, Earth's ability to absorb radiation increases rapidly. That's a huge problem. Okay, next. Yeah, so the amount of radiation reflected by Earth depends upon snow and ice cover, and that determines how much reflected. Remaining is absorbed by the Earth and increasing the temperature. So you can see that on both sides of the equation, absorbed from the sun and emitted by Earth, there is a role in one side played by carbon dioxide, water vapor and methane, on the other side by ice and water. Okay? Both are playing a role. Okay. Next. Yeah, now I put this graphically. One can solve equations, but the best way to understand is the graphic. In this graphic, the dotted line is the Earth emitted radiation to space. Okay? It's called outgoing long wave radiation. Okay? And the black line is the radiation absorbed from the sun. It is not like this, it is an S-shaped curve. Why? Because when the temperature of Earth is very low, like around 235 Kelvin, it's below freezing, so all the Earth will be ice covered. This is ice covered Earth, okay? The so-called snowball Earth, complete snowball. Now the other extreme is here somewhere ice-free Earth. This is present climate right here, and in between comes the last ice age. So what it shows is, for the present value of the radiation emitted by the sun, which we know accurately, there are 3 possible states the Earth could have been. Okay, one is where we are, the other is where we were 20,000 years ago. This was where we were 1 billion years ago. Okay, so all the 3 are possible. Now you can ask me, why are we here and not here? We were there, of course, 20,000 years ago. So the point is that this is not a stable state. One can show this state is not stable. So remember that intersection of the absorbed and emitted is the solution to the equation. LHS equals to RHS in only 3 places, and if you are here and you perturb the Earth a little bit, it can shift to this state. Okay? So even from here it can be shifted if you perturb it. So the point is that today we are in a convenient state called the present climate, and we have to be careful. If you perturb it a lot, it may go either way. Of course, right now we are adding CO2, so it will go to another state which I will talk about. But in the past, the Earth has oscillated between these two with a 100,000 year cycle between these 2 states. Okay? And in the past, the perturbation that was done was natural. And I'll talk about what it is. Next slide. Yeah, the person who proposed what caused the ice age to occur every 100,000 years is a civil engineer who was into astronomy called Milankovitch. Okay? And he was an amazing person. He calculated the exact amount of radiation falling on the polar regions due to changes in the Earth-Sun geometry. You know that the Earth goes around the Sun, and the Earth orbit around the Sun is not a circle, it's an ellipse. And you know that the Earth is inclined toward the Earth-Sun orbit. And you also know that where the Earth is pointing is changing. Okay, let's see the next slide, all these 3. Okay, so the Earth had a circular orbit once upon a time, then it became eccentric. Okay, now this changes occur over 100,000 year cycle. This changes in eccentricity. Okay, this one is the inclination. Right now, all of you know 23.5. It was not 23.5 some years back. It was 22.5 or 24.5. And all of you know that this affects the seasonality of Earth's climate. It was vertical, there were no seasons. It is inclined. And how much inclination determines the season of the Earth. And finally, the most interesting thing is where this Earth points. Right now, the North Pole is pointing towards Pole Star. Okay? But just 10,000 years ago, it was in a different place. Let's see the next slide, I think it's there. Yeah. So look at the condition today, 0K, and 6,000 years ago. Today, the Earth is closer to the Sun in January. Okay? Now, that might surprise many of you because January is a cold month. Okay? But that's when the Earth is closest to the Sun. But 6,000 years ago, it happened in September, not in January. So that will affect the amount of radiation falling in summer in the polar regions. This will not change the regions around Bangalore or Chennai that much, but it will affect the extremes because polar regions, all of you know, have 6 months of summer, 6 months of no sun. So there it matters a lot how much radiation get in summer, because all that radiation will be used to melt the ice. Okay. Next slide. Okay, this is that, it should have come earlier. This is the ice core. This is where the air trapped in the ice core was used to understand the Earth's composition in the past. Now, when Milankovitch proposed this hypothesis that the changes in the Earth orbit around the Sun caused the ice ages, nobody believed him. Why? Because there was no data. He was an unfortunate guy. He was too smart and he was born 100 years too early. Okay? So there was no data to support him. It's all imagination. But luckily, in the last 50 years, we got data from these ice cores, and you'll see what it shows. Next slide. Yeah, this is the ice core from which all the data was taken. Let's have the next slide. Yeah, so this ice core shows something remarkable. So this picture shows three things. The red is the temperature change from the present. Okay, so it shows 4 ice ages, 1, 2, 3, 4. Green is the amount of methane, and this color, dark blue, is amount of CO2. Now don't look at the details. The big picture is the changes in temperature, methane, carbon dioxide, they all go together. Whenever temperature is high, methane is high, carbon dioxide is high. Whenever temperature is low, methane is low, carbon dioxide is low. It's very interesting. So the two are very closely connected. They are not independent. Okay. So this was a remarkable finding, and the changes in the amount of CO2 was anywhere between 200 to 280 parts per million during those times. This is before human beings played a role. Today we are at 415 ppm. Remember that. We are way beyond the natural cycle. Okay. So this showed that the amount of CO2 and methane in the Earth's atmosphere was related to temperature. Now the question is, did the CO2 go up because temperature went up, or CO2 went up and that caused temperature increase? From this graph you cannot decide which is true. Why? This is 400,000 year graph, okay? And the measurements made, although they are remarkable measurements, remember the accuracy of time is not easy. Remember that ice is being deposited and you have to know at what time it is deposited. There are radioactive techniques available for that, but they are not perfect. So when they say that temperature was, let's say, 10 degrees centigrade, let's say 100,000 years ago, the error is of the order of 1,000 years. Exact date we don't know. Okay. So from here we cannot say who started first, who went later. Okay. Now let's go further. Let's go next one. Now here I have superimposed the two curves. Red is temperature, blue is CO2. Okay. In spite of the error in measurement of time, the remarkable coincidence between the changes in temperature CO2 clearly shows that the two are very closely coupled. But the quality of this data is not possible to determine. But I can tell you in the last 10 years, more accurate data was gathered only for this period, last 20,000 years. We have much more accurate data. That shows that the CO2 went up first and the temperature increased later. Okay? So now we know clearly that Earth's climate is strongly controlled by carbon dioxide, and after it increases, Earth's temperature starts increasing a few hundred years later. Okay? If you have time, I'll show how it is done. Next. Now, what you have to worry about is there has not been this much carbon dioxide in the Earth's atmosphere for billions of years. For a billion years, CO2 was between 200 and 280, naturally oscillating with no human interference. Today we have gone beyond that natural limit. Okay? And so that is a very great cause of concern. Why? The first time the CO2 reached 400 ppm in the past million years, past 4 million years, was at this time 3.6 million. At that time, Earth was completely ice free, and the ice and the sea level was 25 meters above the present. Okay? That is mind-boggling result. If Earth becomes ice free due to CO2 increase, further increase, and all the ice in Arctic and Antarctic melt, not all has to melt, even a part melt is enough. If the sea level goes over 25 meters, there will be no Calcutta, there will be no Mumbai, there will be no Chennai, all cities in the coast will disappear. Okay, so it is that serious a matter, and this is not a guesswork. Geologists have shown how sea level changed in the past. They are able to measure accurately based on coastal geological surveys. So this is a real problem, but of course it won't happen tomorrow. You and I are safe. It will happen thousands of years later. Okay, fine. Next. So the very common, I've been giving talk on this topic for the last 35 years, and the most common misconception among many people is that CO2 is only 400 parts per million. How can it affect Earth's climate? It's so small. But the fact is that because the major gases N2, O2 and argon do not absorb any radiation from the sun and Earth, makes CO2, methane and water vapor and ozone more important, because the major gases do nothing. Okay. Next. Now to show them more clearly, you can run today a climate model. Today we have computers, we have models. So we do that work in our center. You model both the land, ocean and the atmosphere together, the whole sphere. You divide the million little cubes and make sure laws of thermodynamics, laws of conservation, laws of mass, laws of momentum, everything is satisfied. Okay, and you march in time, and then you first reproduce the present climate, 50 degrees centigrade. Okay, after that you remove all CO2. Now this, I hope you can see the pink line here. Okay, so the present ice, sea ice cover in Earth around 10%. Okay, now if you remove all CO2 within just 300 years, Earth becomes completely ice covered. So CO2 is that important to Earth's climate that if you remove all of it, we will be completely frozen. So CO2 is very important for us, but you can't have too much of it. Okay, anything too much is not good. All of you know that. So this shows clearly the effect of CO2 increase. The other curves are for change in solar radiation that I will not worry about in this talk. So if sun's radiation changes, of course temperature of the Earth will change, but we are fortunate that as far as we know, sun's radiation does not change much. All the data we have gathered over the last 50 years from satellite shows that the changes are of the order of 0.1%, that's all, hardly any change. Okay, so sun is having some effect of the order of 0.1, 0.2 degree, but not 1 degree change. Okay, next slide. So that's already gone. Next one. Yeah, this is greenhouse effect. All of you know that the CO2, methane and water in the atmosphere behave like a glass in a greenhouse, which allows sun's radiation but traps the radiation from inside the greenhouse. So that's why it's called greenhouse effect. Some people don't like that word, but I think it is reasonably good comparison, not perfect comparative with the greenhouse. Okay, next slide. Now the best analogy of this was given by John Tyndall more than 150 years ago. He said as a dam built across the river causes the deepening of the stream, so when you put a barrier across the Earth's waves, the temperature goes up. Okay, that's a good way to remember. And I can tell you that, I don't know how many of you, I looked at a textbook of Kendriya Vidyalaya about 10 years ago, and there was a mistake in it. Okay? It said that global warming is occurring because CO2 absorbs sun's radiation. That is completely wrong. Okay? If you have read that, please forget it. CO2 cannot absorb much of sun's radiation. CO2's role is it absorbs Earth's radiation, and they are very different. If CO2 absorbs sun's radiation, Earth will be cooler, right? It will trap the sun's radiation. So it is not doing that, it is absorbing Earth's radiation. So remember that it is the terrestrial rays that is important, not the radiation of the sun. Okay, next slide. Okay, this is already covered, sorry. Next. Yeah, now let me conclude the past changes in Earth's climate according to Milankovitch, that due to changes in Earth's orbit, the amount of radiation in the polar region in summer increased during one event, and that caused carbon dioxide to come out of the ocean and land, methane coming out of ocean and land, whatever goes up by laws of thermodynamics. All these cause greenhouse effect, trap more radiation and increase temperature. This is called positive feedback. The word positive feedback comes from control theory. It is somewhat misleading. Positive is not good. Positive is bad. Okay, remember that. So when I give a talk to businessmen, they think of positive being good. But unfortunately, here positive means it is going to add to your problem. Okay. Same thing happens when temperature goes up, ice melts, because water absorbs more energy. This is also, there are two positive feedbacks, two chain reactions, which will add on to the initial change, and it's not good. It's going to go in one direction. We want a negative feedback. Something should change such that it negates the initial change. Okay. Next slide. In addition to the sun, of course, we also have effect of the volcanoes. Now and then there are huge volcanic eruptions, and they put out huge number of particulates called aerosols, and they reflect sun's radiation. Okay. So now whenever there is a volcanic eruption, the Earth's temperature goes down for a short time. Remember that these particles that are put out by the volcano cannot remain in that much long time. CO2 remains long time. CO2 is there for the next couple hundred years. Okay, it's a gas. It doesn't condense. But particulates are solids or liquids. They will fall down. So when a volcanic eruption occurs, next slide. There are so many eruptions took place in the last 150 years. Okay, let's go next slide. Yeah, so Pinatubo was the last one, 30 years ago. When it erupted, the temperature dropped by around 0.6 degrees, and then it recovered. Once the aerosols settled down, it recovered. So although volcano has an effect on Earth's climate, it's only for a short time, not for a long time. Okay, let's go on. So another thing I want to remember that although volcano is very important in Earth's long-term CO2 balance, but the amount of CO2 coming out of volcano is much smaller than what human beings are putting up. Okay, this is something many people don't realize. See, volcano is very dramatic, erupts in a big way, and you say, wow. We human beings are erupting every day. The CO2 is coming out, every action of ours, CO2 is coming out slowly, every day, every night, and it is accumulating 100 times faster than the volcano. Remember that. Okay, so next slide. Let's look at 20th century. In the 20th century, what happened? Next. Now, in the 20th century, you compare the temperature in blue with CO2 in orange here. You can see that from 1960 onward, the changes in temperature and CO2 are going together. Okay. Before that, they were not, because before that, both natural changes as well as human beings were playing a role. So sometimes the Earth temperature dropped, although CO2 went up, because something else happened in the Earth system. Okay. But beyond 1960, the human role is very clear, human impact. Okay, next slide. To make sure we understand that, we all run climate models. These models contain various levels of the atmosphere and the ocean and land. All these are modeled, and we integrate this in time. And one advantage in a model is I can say let CO2 remain constant and see what happens. So you can do thought experiments which are very good. Okay? Let's see what happens. So if you run a climate model with CO2 constant many times, hundreds of times, you get this result. That temperature changes only by around 0.2 degrees up and down. But if you let CO2 increase, you get the red line or the orange line. Okay? And black is observation. So this clearly shows that from 1960, the observed increase in temperature can only be understood if CO2 is about to increase. If CO2 does not increase, the Earth temperature remains fluctuating around 0.2 up and down. Okay? So this is a clear proof that the increased temperature in the last 60 years is mainly due to increase in CO2 due to human action. Okay, next slide. Yeah, so remember last 20 years temperature has gone up more than 1 degree centigrade. Now many people tell me 1 degree is not much, but remember this happened in 150 years. But look at the past. When we came out of the ice age, the temperature is 1 degree in 1000 years. Okay? So not only we are increasing temperature, we are increasing at a rate 10 times higher than ever that happened in the past. That is the serious concern. That things are changing so rapidly that neither human beings nor plants nor animals can adjust to it. Remember that the long evolved life on Earth, adjustment took place over a long time scale. Animals can adjust, birds can adjust, provided the change is slow. The change is very rapid. For example, when the temperature goes up rapidly, plants, especially animals will move because they can move. Okay? They will move to a, let's say, more northern latitude for a cooler climate. Trees cannot move, right? Trees are in trouble. They can't move. But trees are much smaller than animals. I don't know how many of you know. All the drugs we get from our pharma companies come from plants. Because they cannot move, they are much more smart. They find various ways to fight the environment. So plants will have various variations. In case the temperature goes up, it will produce a kind of plant which is more resistant to temperature. It will change. But it will take time. It won't happen in 10 years. It will take thousands of years. So the main concern is we are changing the temperature of the earth too fast. So natural world cannot adapt to it, and even human beings will have difficulty. Okay, next. Now what's happening last 100 years? Because the temperature rise rapidly, this is 1,400 years of data of the sea ice, and see how rapidly it is falling. The sea ice in the Arctic is changing very rapidly just in the last 100 years. Before that it was stable for thousands of years. Okay, next. So because of the increase in temperature in the last 100 years, the following things happen. All of us are experiencing that right now. That is, heat waves have increased and they are occurring more often. They are longer, and the first heat wave is coming now in March and April. Okay, and the hottest day of the heat wave is becoming hotter. So all this is bad news for all of us, because human beings, remember, can only handle temperature if it is below our skin temperature. All of you know my internal body temperature is 37 degrees centigrade, which you measure with a thermometer. The skin temperature is 34, 35. So because of that, I can conduct heat and get rid of heat, and also of course evaporate. But if the temperature above becomes above 35 and I cannot evaporate, that happens when the humidity is 100%, then we are in trouble. Because as I'm talking to you, I'm generating 100 watts of heat. If that 100 watts I cannot get rid of by evaporation, I will die. Okay? It has happened. There were soldiers, American soldiers in Vietnam, in the height of summer, they were carrying a backpack of 100 kg and walking in the rice fields. And at the age of 25, they dropped dead because their body could not control the temperature. So remember that if temperature goes up too high, many parts of India will be not livable. Okay. Next. And heat waves are increasing. The number of heat waves globally going up rapidly in the last 20 years. Okay, next. Next slide. Yeah, all over the world you can see heat waves going up. And a good example is about 15 years ago, the Chicago Marathon was cancelled because it was too hot. Now what I want you to remember is, if elite athletes who are much better than all of us, if they cannot handle the heat, you and I are gone case. We cannot handle it. Because these guys are tough people. They can handle all kinds of conditions. They are not able to handle that heat. So remember that conditions are being quite bad in terms of heat waves. Okay, next. Now, because of the increase in temperature, the moisture goes up in the atmosphere, and because of that, extreme weather events are increasing. Storms, floods, droughts, all are increasing, and this is the increase in Asia from around 100 per year in 1980. It has already gone up to 300, 400 by 2010. Okay, so that's a major concern. We are seeing more heavy rainfall, more floods because of increase in temperature. Next. Now, although we cannot handle it, insects are ideally suited for hot weather. All of you know it. And when summer comes, the insects come out from anywhere. Now this is a beetle, okay, which is eating away the soybean plant when there is high carbon dioxide. Okay, this is a lab experiment. So if CO2 goes up and temperature goes up, who is the beneficiary? Insects, not human beings. Now it's already happened. If you look up now, go to Canada. Next slide shows. In Canada, large millions of acres of forests have been killed by beetles. Bark beetles have grown rapidly because of temperature rise. Because Canada is a cold country normally. But when the temperature rises and becomes warm, the insects love it. They kill the trees, and your dead trees in millions of acres. Then what happens is that the dead tree, next slide shows, the dead tree will get a lot of forest fires. Next slide. Huge forest fire. This is in Russia, not in Canada, but they're all the same latitude. So all of them are having huge forest fires because of lots of dead trees killed by insects, all because of temperature rise. Now I want you to get an idea. We in India don't understand the scale. See, this area of fire is the area of Karnataka. Okay? Imagine the entire Karnataka going up in a forest fire. Luckily it does not happen because we don't have too much forest left in India. But this is the scale of the problem because of temperature rise. Next slide. Let's go to the final part of the talk. What will happen in the next 100 years? Okay. Next. Next slide. Yeah, so we are rapidly going up. We are doing nothing, just CO2 is going up. It's already crossed 400. It will cross 450 definitely and may even reach 500. That's what the cause of concern is. Next slide. Now, we saw what happened in the past. The climate was driven by changes in sun's radiation in the polar region. Now, the agent is human being. We are increasing CO2, temperature goes up. Whatever goes up by classical Claption equation, there's one reaction, the other reaction is melting. So today this is the loop, different from the past. This is the human being the agent. Okay, next. Now what's going to happen? So we run climate models. They show that by 2100 temperature may rise up to 4 degrees centigrade. Which, how high depends on what we do in the next 100 years. Okay, next. Now we in India have to worry about it. Why? Imagine most of India is what is called savanna, because our rainfall is around 100 millimeters and our temperature around 25 global, the annual mean. We are somewhere here. If the rainfall goes down and the temperature goes up, we go from here to here, which is a desert. So we have to be careful because going from savanna to desert can happen, has happened in the past. So most of India will become like Rajasthan. Okay, so that's what we have to worry about. Next. Now, what is the prediction for crop yield? Remember, the crops also are subject to heat stress. As the temperature goes up, your crop will not yield well. So this is a simulation done by UK Met Office, and they are showing that the developed world, which is under colder climate like Europe and North America, Canada, their yield will go up because CO2 increases, photosynthesis increases. Okay, so they will benefit. But country like India will be in trouble. Okay, so this also causes a concern. Not only temperatures are hotter, your yield of your crop will go down. Okay, next. Now this is showing that all the crops we have developed over the last 10,000 years are around 25 degrees centigrade temperature. They work well. Yield goes on either side. It's too cold, the crop will freeze over. If it's too warm, it will not. So we have developed crops over the last 10,000 years to work at about 25 degrees centigrade. That is annual mean temperature in tropics. If it goes up, your yield will come down. You cannot do much. But of course, there are a lot of good research going on. We may develop new varieties, which may overcome it partly, but we need to be careful. Next. The other part, of course, sea level rise. I mentioned it already. Now, sea level rise is already occurring. 20, 30 centimeters rise already occurred, and it will increase further. But the problem is, sea level rise is occurring at a time when many land are not extracting groundwater, or if we do extract, we charge it back, so that the soil is not become, that is without water, becomes like a vacuum. Okay. Oh, we'll come back. I can see that. So the point now is that having seen how bad the situation is, if we do nothing, then the temperature will keep going up. So in 2015, 7 years ago, all the countries met in Paris and agreed that this cannot continue. So all the nations agreed that they will voluntarily, they will try to reduce the CO2 emission. That's the Paris Agreement. It is not binding, it is voluntary, so we have to see how it will go on. So the agreement in Paris is that all of us will reduce our CO2 emission such that the temperature rise is not 6 degrees, but more like 2 degrees or less if possible. Okay. Yeah, so this is where we are going, and we want to go on this trajectory or even lower. But so far, nothing has been done. But we are hoping that what I call good sense will prevail and something will happen. Next. Now, what is India's predicament? India's problem is we contribute hardly 6% to the global CO2 emission. And so, see, remember that whether CO2 is emitted in Beijing or in Washington or in Moscow or in London, doesn't matter, it will go everywhere. It is uniformly mixed. Okay, it's a gas. So once it's released, it travels very rapidly along the path of wind and it's mixed uniformly. So we have to make sure that not India alone, the whole world cooperates to bring down the CO2 emission. That's not easy, okay, because we are now only wanting to blame each other. So, so the Paris Agreement, for the first time, everybody agreed that there is a common problem, all of us have to work on it, but India will have a tougher problem because we emit far less than most countries in the world. Okay. Next. So this is where we are going. Now we want to go here. That's the plan. Okay, next. So in Paris Agreement, some agreement was made to bring it to around 3 and below. Now we have to work further to bring it to 2 and finally to below 2. Okay, that's the plan. Okay. Next. Yeah, so this is the story now. We came from the last glacial ice age to the present about 10,000 years ago. Now if we do nothing, we may go to a much warmer climate in the future where there will be no ice at all on Earth and temperatures are much larger, maybe 4 or 5 degrees larger than present. Okay. Now, why should we worry about it? Because of this warming, lots of things on Earth will start becoming unstable. Okay, like the ice sheets here, even the monsoon may misbehave, and a large amount of methane trapped in the colder parts of Russia, they will all come out. So lots of things are there which are called tipping point. That is, you go beyond certain point, more worse things will happen, more problems. Okay. And one example is the methane is coming out of the into the ocean here and into land here. You can light a matchstick and it will burn. So methane you cannot see by eye, but you can show that methane is there by lighting a match. Okay, next. Now one more fear we have is that as the ice melts in Greenland and other places and falls into the ocean, it will alter the ocean's salinity. Okay? Ocean has a certain amount of salt, and if ice falls in there, its density will change. The ocean will stop circulating. If ocean stops circulating, it has a huge impact on the global climate. So this is the current worry, whether we can stop that, what they call Atlantic Meridional Ocean current. That is, its current will travel from tropics to the polar region, which takes heat from the tropics, brings it to the poles. If that stops, it's a huge problem. It has happened in the past, naturally, but now we may be forcing it. Okay. Now you can move on. Doesn't matter. Can you move on to the next slide? Yeah. So that I will not be able to show you. Then move on. We'll do one thing. We'll stop here. Let me have some questions first. If the power comes back, we'll say a few more words. Anybody has any questions so far? Anyone? Yeah. Yeah, you don't use mic. That fan noise, I can't hear.
Sir, you told that carbon dioxide emissions which will trap our Earth's radiations and it will also affect our crops in India grown. So how does it affect the cropping patterns, sir, all over throughout our India? And also does it affect our agriculture sector and the economy also?
Yeah, this is CO2 as it goes up, it is good for the plants. Okay, photosynthesis, plants will increase. But temperature increase is much more serious. Remember, plants like us have to maintain some temperature in the leaf, otherwise the plant will wilt. Remember, plant all the time, they try to get moisture from the soil to balance evaporation, right? So if the temperature goes up a lot, evaporation increases, the plant cannot get enough water. So the biggest challenge we have in India is the temperature issue. But if you are in Russia, where it's very cold, the temperature increase is good for them. Okay. As a matter of fact, about 10 years back, we had an Indo-Russian climate change workshop. The Russians said, no, we want climate change, it's good for us. But they are wrong. There are some benefits, but there are a lot worse things will happen in Russia due to higher temperature. I don't know how many will know. About 2010, there was a heat wave in Moscow, and the temperature was 20 degrees above normal, 20 degrees, okay. Just to give you an idea, if Bangalore temperature went above 20 degrees, it will be 55 degrees centigrade. We can't live, okay. So in Moscow, it went up to 30 degrees, which is very nice, but people in Moscow are used to cold weather, and there's no ventilation. Everything is closed there because the cold climate. So people died at 30 degrees centigrade. Okay? You may not believe it, but it happened because that's a different climate. Okay? We have climate where we allow air to come and so on. There we want to control ventilation. So the point is 20 degrees above normal is kind of thing can happen. So it's happening regularly now in Europe. Europe in 2003, 20,000 people died due to heat wave. 20,000. Okay? Mostly poor people and mostly old people died. And so this is the problem. So in the case of crops also, temperature is bad for the crop. CO2 is good, temperature is bad. But if you do irrigation, of course there's a benefit. If you irrigate the crop, it will manage reasonably well.
So most of the farmers in our India depend upon the rainfall itself,
Yeah,
sir.
they'll have problems.
So that is the problem, sir.
Yeah.
So if the climatic change occurs rapidly and the cropping patterns will also be affected in our
Yeah,
India,
I
sir.
what's going to happen? If you remember, in India's past, in a state like Karnataka, they didn't grow rice. Huh? They were growing ragi. Why did they grow ragi? Because ragi is a crop that can handle drought, can handle hot weather. So we have to shift, that's all. So I think India is putting too much land under rice. It requires irrigation, it requires low temperature. But there are other crops available which can handle the tough conditions that prevail there. So if you look at the long history of human beings in India, they had, in India about, I would say 500 years ago, farmers had 40 varieties of crops, not one, 40. So on a given land, they will throw all the 40 varieties because they don't know what will the monsoon will be that year. So some crop will benefit by that climate. So we have to get more smart. We have to have variety. India's Agricultural Research Institute, they are spending a lot of time in developing new kinds of crops which can stand the heat they are developing. But there's a limit. If you go 5, 6 degrees more, I don't think any genetic engineering can work. But for 1 or 2 degrees, we can manage with a different kind of variety of crops. We can do that.
Thank you, sir.
Yeah, anybody else? Anyone at the back? Okay, let me finish that. So this is that current I've talked about, the ocean current which takes warm water from here to the bowl. This may come to a stop if a lot of melting of Greenland takes place, okay? Yeah.
Thank you for enlightening talk, sir. Now we have few online forums questions also.
Sure.
Could you please address
Yeah.
it, sir? The first question is, what kind of daily activities are enhancing climate change? It is by Dr. Vijay Kumar.
Radioactivity does not affect climate. Radioactivity is a,
Daily activities,
Huh?
sir. Daily activities.
what do you mean?
Day by day activities.
Daily activity. I don't know.
Climate change.
Oh, very simple. We are all burning fossil fuels. When you drive in a car, when you go in a plane, when you use fertilizer in your crop, all these are daily activities which increase CO2 emissions, right? So as a matter of fact, unfortunately, let me just make a simple statement. The last 100 years of amazing progress in our civilization is because of the use of fossil fuels, okay? Coal, oil, and gas. Unfortunately, that has created this problem. So in the future, we have to change. We have to move away from this and go to renewable source energy like wind, solar, and water. That's what India was doing for few thousand years. Remember, till 1850, we didn't have coal, we didn't have oil, we didn't have gas, we were managing quite well. Only last 100 years, we got greedy and started mining it. That is, every activity of ours is related to CO2 emission. Okay?
Okay, sir. The next question is from Sonali Sharma. The question is, climate change is something that is impacting women on larger scale. If there is scarcity of water or any nature disaster, then women become worse sufferers. So how do we devise our policies in such a way that we can protect this vulnerable society?
Yes, that we all know. As a matter of fact, I can tell you, The worst example is the heat wave in Europe. Most of the old people died, majority of them are women. Heat wave affects women more than men. And so you're right, climate change is affecting women much more than men because they are the ones getting the water. So to me, the best way to handle that would be the way you use your water. We in India have taken our monsoon for granted and we waste a lot of water. Okay? That's all right when a population was 1 million hundreds of years ago. But now we are 1.4 billion, we can't afford to waste water. So everybody has to learn how to conserve water and not demand that this river should be changed to come to Bangalore. For example, Bangalore is living off diverting Kaveri water in a big way, okay? And denying water to many villages downstream. So this has to change. Everyone has to learn. For example, if you remember, during the British time, when Kaveri water didn't come to Bangalore, Bangalore was managing with all the lakes we had. It's possible. Okay? If you have 100 lakes in Bangalore, the groundwater will be replenished, the rainwater will ultimately go on the ground. That we have forgotten. And we are asking for more water from Kaveri and more water. As a matter of fact, I hear that they want to divert water from Joe Falls to Bangalore. Can you believe that? There is a plan. You can look it up. Okay? This is shocking. This should not be allowed. Why should people in North Karnataka supply water to Bangalore? Right? So we are doing a lot of stupid things because of the power of there is a vote block of urban voters, okay, who control our politics, unfortunately. So powerful people in Delhi has diverted Yamuna water to itself, okay, denying water to Haryana and Punjab. So this is happening everywhere. So it's high time we realize that water is a precious commodity. We cannot waste it, and we cannot be growing crops like rice and wheat which demand a lot of water. And we have to learn to live to conserve water as much as possible. Okay.
Sir, the next question is from SM Haripriya. She's asking, how does carbon footprint affect climate change?
The carbon footprint of the world to indicate how much carbon dioxide is released by human activities per person. Okay? How many tons? For example, Indians are at the rate of 1 ton per year. Americans are 20 tons of carbon. Okay? So in the next few years, all of us have to learn what is your carbon footprint. That depends on whether you drive a two-wheeler or a car or you go by a bus. All of you can go look up Google website where you can calculate. It will ask you the various activities you do and how much your footprint is. I'm sure in urban India, most of us are around 4 to 5 tons per capita per person. In rural India, it's very low. Okay? All India is 1, but that's because most rural people are not involved in much carbon footprint. Only the urban people are. So we have to learn to reduce our footprint.
So one more question. Generally, it is believed that developing countries emit more carbon dioxide due to increased use of fossil fuel. How is the case in other developing countries? Do they also use more fossil fuel to emit more carbon dioxide?
I think the key point is developed countries are emitting more carbon dioxide per person. But there are a number of people in the developing world is much more. So we are now becoming the major emitters, not because we emit more per person, because there are more people. Remember that. So as a matter of fact, if you plot the carbon dioxide emission per person, it has not changed. Okay? As the population goes up, there is more CO2 emission because each human being in his activities has a minimum carbon footprint. That you have to realize.
Okay, sir. Now the question is from Asta Shetty. The question is, what can students do for the cause apart from spreading awareness on climate change?
Yeah, what I would argue is that first of all you have to convince your parents, because some of the older people are not that aware. So you have to convince your parents and your teachers also. But secondly, you also have to ask yourself whether the actions you are taking is causing more CO2 emissions. Each one of you have to become aware of everything that you do every day in life, how much CO2 emission it involves. So the awareness has come to everyone, and also you have to convince others. And essentially I would say that is something which young people don't like. Now in the last 100 years, people have got used to personal mode of transport, car for example. I don't have a car, I can say that that is not a good way to go. So as far as possible, we must move on public transport and reduce the use of car, which is not a sustainable option. Okay? Each year, you won't believe it, 68 million cars are sold per year. 68 million. And they're all depending on oil. That has to go. Okay? So young people get very upset when I tell them, but good news for you, the last 10 years electric cars have come and they run faster than car running on petrol and diesel. You will get it. You can enjoy that without any feeling of guilt, because as long as that electricity that you give to the car comes from hydro or solar or wind, you are not doing any carbon footprint. Okay, so all of you will enjoy, I'm sure, electric vehicle, which is coming in India slowly. A lot of electric scooters already come. There are 1 million in India right now, electric two-wheelers, but even cars will come. But you can imagine, India has such a high population density. If each one of us had a car, there's no place to go. All of you can see in Bangalore itself, the cars have gone up so much in the last 10 years, there's no place on the road, right? So it's not a practical option for everyone to have a car. Okay? So you can have a good public service, public transport running on electricity, and that's the way to go. Okay?
Thank you, sir. That was a very informative lecture.
Okay, just run through a few more slides, we'll come to a stop and have a break. Okay? Just a few more slides. Can you go further now? Go further. Next. Yeah, this was the one. Next. Next slide. Yeah, about 10, 15 years people thought that we cannot manage without oil, coal and gas. That's not true. People thought that renewable energy is not reliable, it's not efficient, it requires large land. All this is not true. Costs have come down. Today, entire India can be run on solar, wind and water. So there is a way out. It is not impossible. Next. Now I want to end on this note. Remember that global warming is not the only problem we are facing. We have done so many terrible things the last 100 years that we create the ozone hole, which fortunately now is being controlled. We have reduced air quality, we reduced water quality, of course, and climate change. So there are many things happening, soil degradation. So all these have looked at together. Climate change is just one example of the problem we have created. We have created many other problems. They're all connected to the way we live our life. If we live our life in a very careless way, all this will happen. If you're a little more careful, we can cut down the unsustainable way in which we have done things in the past. Okay? Now let's conclude with one slide. So the final message is, climate is changing. Yes, human beings are responsible. It is bad and we can control it. Okay, thank you.
Thank you so much for that informative lecture, sir. I'm sure we all have benefited maximum in the session.
So I just want to, so thank you so much for, Professor J. Srinivasan has given this book as a reference. The gist of this book goes like this. This is an inspiring, informative, insightful meet of some of India's most celebrated female scientists. What led them to choose their particular field? Who encouraged them? What were their struggles? What are their sources of inspiration? What are the key questions of the cutting-edge modern research? Why choose a life in science at all? From astrophysics to zoology, learn what it takes to make a career in sciences. So he has gifted this book to our college, a very thoughtful gift, sir. Thank you so much. And this book has been edited by Ram Ramaswamy, Vice Chancellor of University of Hyderabad, Madam Rohini Goldbale, Professor of Physics at Indian Institute of Science, Bangalore, and Chair of Women in Science Panel of the Indian Academy of Sciences. So I just want to also add one more thing about Madam Rohini Godbole. She was awarded Padma Shri Award last year. And also by Mandakini Dubey. She is a freelance editor who has taught writing and literature for many years. So this book is going to stay with the Department of Zoology, and this is a book to inspire all of you to become the future scientists. So please come and borrow this book and get inspired. Thank you so much. Thank you so much, sir. So now we have a small event of planting of the sapling. So I request the dignitaries and to please join the occasion. So we'll just set the stage in a minute.
Ma'am, can I just add one more sentence? Sir has volunteered to give more copies if they are requested by the organization. So we'd be happy to give more
Definitely, ma'am.
copies for the library.
We want all our students to become the scientists and also, copies in the library.
Yes.
Yeah. Thank you so much, sir, for your kind gesture.
Recording stopped.
Please join all of us. Please join the dignitaries while we plant the sapling, so which will be later shifted to a place on the land and the soil where it will be deeply rooted. So this is an occasion of the Golden Jubilee celebration which Department of Zoology is conducting on behalf of the college. So this is going to remain as one of the marks we are going to left behind on the occasion of the Golden Jubilee celebrations. So we request Professor J. Srinivasan and Dr. Anil Kulkarni to join, please. And also Principal Ma'am to join the occasion, please. And Samitri Ma'am, sorry. She is the force behind in organizing this program. Yeah. I request all the department colleagues to quickly come for a photo session. Girls, please remain seated. So we are going to start the next session quickly. Right. To all the participants, you can be seated, the refreshments will be served. We'll take a 5 minutes break. Those who want to just go for a bio break, go and come back quickly. So refreshments will be served, so then we can we'll start the next session without much delay.
Please leave your bags and come back.
Dr. Anil V. Kulkarni sir is a distinguished scientist at the Divecha Center for Climate Change, Indian Institute of Science, Bangalore. Sir has acquired a post-graduation degree in applied geology from the University of Roorkee. Sir has obtained a master's degree in geography followed by a doctorate in geology from Shivaji University, Kolhapur, Maharashtra. In 1987, Sir was awarded a Commonwealth Fellowship at McGill University, Montreal, Canada. Sir have published around 120 papers in prestigious national and international journals. These published papers made Sir to be in the top 2% of researchers worldwide in geological and geomatics engineering. Dr. Kulkarni sir was conferred with the prestigious National Award in Polar Science and Cryosphere in 2014. and National Geoscience Award in 2009. Sir also received a Team Excellence Award in 2008 from the Indian Space Research Organization. Due to the climate change, the temperature is increasing day by day. We all are experiencing it by sweating more and more. Even glaciers in the Himalayas are melting at an exponential rate. According to the new research that shows the massive ice sheets in the region have shrunk 10 times faster in the past 4 decades than during the previous 7 centuries. So, Sir has developed many remote sensing based methods and models to understand the Himalayan cryosphere. The methods are widely used to map snow and glaciers. The models are used to assess glaciers, mass balance, stream, runoff, and the influence of climate change. This was just a brief introduction of Sir. Now, without wasting much time, I welcome Dr. Anil V. Kulkarni Sir and request to deliver his lecture on Himalayan glaciers. Welcome you, Sir.
Good afternoon to all of you. And thank you very much for your nice introduction. And it is indeed always difficult to talk after Professor J. Srinivasan because he is a prolific speaker as well as one of the topmost intellectuals in the field of climate science. So let me see what justice I can do to topic. And the topic is today is about climate change and Himalayan cryosphere. So you must be wondering what is the meaning of cryosphere. Many of you are quite aware of this, and the region of the earth where the water remains in a solid form is generally called as cryosphere, and we are extremely fortunate is it working? Okay. All right. So we are extremely fortunate because in Himalaya, which is the northernmost border of the India, we have large amount of region which is covered by snow and glaciers. And the advantage of snow and glaciers is that the snowfall takes place in winter, and some of that gets accumulated over a period of time in the form of ice into the glaciers. And they melt during summertime because we already know that summertime we have difficulty of getting water. So there is a time lag between the precipitation which receives into the mountains and when it is released through the Indian river system, and making many Indian rivers, particularly North Indian rivers such as Ganga, Brahmaputra and Sindhu are perennial rivers. Otherwise you can see they would be like rivers like what were Kaveri or Krishna rivers on the peninsular India. But it is very important for us to understand, because I am going to talk this terminology very quickly in future. So it is important for us to understand what is the difference between the snow, ice and glaciers. So what is the snow? You probably, if you ever happens to go to the North India, Manali or any other place in Sikkim or any other place in winter time, probably you know that snow is a porous and permeable aggregate of ice crystal. So it is, and you can see it is extremely white, and in between there is a lot of air which is trapped, and sometimes even water is trapped between the ice crystal. That makes it a snow. When the interconnection between air and water passages are removed and sealed off, that means the amount of air between the two ice crystals is substantially removed, it solidifies and the ice is formed. And when this ice is formed and it forms in a large magnitude into the mountain, because of the gravity and because of the internal deformation, it starts moving along the slope of mountain valley and the glaciers are formed. And Himalaya has a large amount of, and how they look like into the, if you take the photograph, you can see here, this is a fresh snow which is the following into the Malani region of Himalayas. You can see here even the vegetation which is completely covered by snow and it looks extremely white. When it gets converted into the dirty snow and patchy snow, the earlier Professor Srinivasan was talking about the albedo, and that means the ability of that surface to reflect the solar radiation is significantly reduced. You can see here it is extremely white. It is slightly reduced over here, and you can see that it becomes a patchy snow. It is in between the snow and ice now. That is generally called firn, and then when it becomes the ice, it can become a crystal clear. It is extremely clear ice. So, but the glaciers are different than this. It is something which is, you can see the glacier ice will look like this, because in between there's a lot of dust particles and it reduces albedo quite significantly. And if you take the photograph of glacier, this is a glacier which is taken into the Lahul Valley and Himachal Pradesh. You can see that how glaciers will look like. This is the snow which is on the higher reaches of glacier, and this is the ice which is exposed on the surface. You can see that since the glacier ice, on the surface there is a lot of rocks, because you can see these are the rocks formation. It will fall because of the erosional process onto the surface of ice, and it will become a very different color for you. So the ice and glaciers are quite different things when it comes to the landfall, because ice will essentially have water, it will ice, glaciers will have ice, water, debris into it. So we have to understand this thing. So why it is so important for us to study and what impact it will have on Earth if it really really melts. So if you look into the Antarctica ice sheet, we are approximately 13.3 million square kilometer area, and if it really melts completely, sea level can rise by 56 meters. If you look into the Greenland ice sheet, if it melts, it can go as high as 7.1. The mountain glaciers, including Himalaya, Alps, and Andes, if they melt, it can be around a half a meter to 1 meter it can grow. And then there is the permafrost also. So the permafrost is a region of the earth where soil is permanently under frostic condition. That means the soil is form of, there is no water in it. Instead of water, there is ice in it, and that is also can melt. So if you really look into all, if we really remove all ice from the Earth system, then it's quite possible that sea level will rise by 64 meters, and it is huge. You can imagine those of us who are coming from the coastal region, like coastal region of Karnataka, or whether it is visited Mumbai or you visited Chennai or any other place, 64 meters can really inundate most of our infrastructure and most of our housing and so many other things. So it is indeed going to be a major thing for humanity to understand how cryosphere is going to. So what is the importance of cryosphere? In the context of Himalaya, we are going to talk today is extensively snow and glaciers, because we know that Himalaya has large area under seasonal snow and as well as glaciers, so they release significant amount of water into the Indian river system. So it is used for hydropower generation, irrigation and drinking purposes. How it is going to change? If the cryosphere is going to change, how the power generation capacity is going to change, how it is going to affect the irrigation, particularly on the Indo-Gangetic plain. Because you know that Indo-Gangetic plain is the food basket of India, and almost 60% of food grain of India is produced in Punjab, Haryana and western Uttar Pradesh. So we really want to know how it is going to affect, and drinking is of course. The glacier melt, we have already seen, can significantly change the sea level. As glaciers keep melting, they release the land. What it means that the land which is now covered by ice is now released. That means ice is gone, so the rocks are exposed on the surface, and it creates a new hazards for the people which are living into the mountains, or those are in the surrounding areas mountain. It can create huge avalanches, it can create floods. We will look into some of those cases of past, how floods were generated into the Himalayas, and there could be iceberg, you know, the famous Titanic story. So it can release huge icebergs into the ocean, and of course you can take care of this because of the news. There is also climate. The albedo effect will modulate the climate, which Professor Srinivasan was talking about it, that how albedo of water and ice is very different, and because of that it can going to change the energy balance of the earth. We can also going to lose our past record if there is no ice. So in Antarctica, whatever we have studied about past, by using ice cores, then there is no ice, that means there are no ice cores and there is no data. And it can really affect the landscape, erosion, landform, ecology of the region. We will look into those aspects, how ecology is going to affect. Some of that might be of interest to you, being some of you are being a zoological background. So how it is going to affect the ecology. So let us understand how Himalaya is, because Himalaya is not one mountain. There are series of mountains in the Himalayas. So as you move from south, to north, have you ever gone from Chandigarh to Manali? And if you go via Kirpur or that region, there is one small mountain range you can see. First mountain range, which will be like this, and the Bhakra Dam is on that mountain range. And then you can see, it is not plotted here, but that is one mountain range, and there are no glacier along that. That is known as Shivalik mountain range, and there are no glaciers along the Shivalik mountain range. Then if you go to Manali and cross Manali, go to Rohtang Pass, if you have ever gone up to the Rohtang Pass, then you have this mountain range which is called the Pir Panjal mountain range. If you continue to drive further along that road and you want to go to Leh, then you will come in another mountain range which is the Great Himalayan mountain range, and this is really throughout it starts from Jammu and Kashmir and it goes up to the Arunachal Pradesh and beyond that in Burma also. So this is a major, which is the pan-Himalayan, that means from Jammu and Kashmir up to the Arunachal Pradesh and Burma, you can see this mountain range. And then there are smaller mountain ranges. This is the Ladakh mountain range, and then at the end there is the Karakoram mountain range. Because if you look into if you are following the literature of glaciers, there is a huge talk about the Karakoram mountain range. So you have to understand where they are distributed, and all these mountain ranges on its southern faces or northern faces, there is a huge glaciated terrain there. So you can see, but there is also difference where from that snow is coming. Because the different regions of Himalaya receive snowfall from different systems. If you come into the western Himalayas, particularly this part of Jammu and Kashmir, Himachal Pradesh and part of Uttarakhand, you can see that most of the moisture is coming from winter, westerly. That means the winter time you receive the significant amount of snowfall. And if you are going into the Sikkim or Nepal, Bhutan or Arunachal Pradesh, you can see that most of the Indian monsoon, which is summertime, moisture it is receiving. So climatically, they receive moisture in different type of years. And because of that, their sensitivity is also significantly developed. So we have to understand. So if you go into Sikkim and you want to study the glaciers, you can see that you have small peak in winter and big peak in summer. Because they receive more precipitation in monsoon time. So we have to realize how, so the future climate change, how Indian monsoon is going to affect because of the climate change is also great importance for glaciological study, as well as how this western system, which is coming to Central Asia, How it's going to change is also important for the glacier system. But as you know, earlier Professor Srinivasan is talking about the global climate change, but particularly in Himalaya, issue is slightly more than that. Because if you see the global climate change, if you look into this data, which is work which is done in the Indian Institute of Tropical Meteorology, you can see here in early 50s and 60s and 70s, this is whatever, this is India, and this is all over India, and this is Himalaya. You can see that as compared to the India, Himalaya was much cooler. And if you come in this part, if you come into this, particularly after 1980, you can see that Himalaya is much more warmer than rest of the India. What it means is that as you move high into the atmosphere, the warming is higher than global mean, and if global cooling is there, it will be more cooling than global mean. So it is very important for us to understand that if Paris Agreement tells you about we want to stabilize global temperature of 2 degrees Celsius, it probably means something between 3 to 4 degrees Celsius in Himalayan region. So that understanding is there, and we have to be very careful, because then you are going to have magnifying effect on Himalayan cryosphere than originally people thought it's going to happen. In addition to that, there is also something else happening into the mountain. That means there is increasing precipitation in form of liquids, which is the rainfall, and there is a decreasing precipitation in form of snowfall. So there is no actually decrease in precipitation, but its solid component is reducing and its liquid component is going up. So all this thing is significantly going to affect the Himalayan cryosphere. So let us understand first how much we have in Himalaya. We have three, as we are talking about, we have 3 major river systems into the Himalayas. One is Indus, one is Ganga, and another is Brahmaputra. So you can say how much amount of water stored in the form of ice into this system, because this is the work which is done at Deveka Center, which is, and you can see here we have approximately around 2,000 cubic kilometer. Remember, it is cubic kilometer. It is huge. And then you can around 600 in Ganga and about 900 in Brahmaputra river basin. So it is huge. And then how much they are contributing? Are they contributing very significantly into the water system or not? That is also very important for us to understand. So one thing you can see here is, this is the work which is very recently published by our team. You can see that some of the region, you can see here the red, which is greater than 75% amount of snow and melt contribution in total and annual basis, how much you get the water from snow and melt in a system. So you can see the Indus basin, it depends upon where you look, but high altitude you can see as high as 75% of its water is coming from snow and glacier melt. And as you come down, it slightly reduces. As you move from west towards the east, then also the concentration percentage is reducing. So what you can see from this side in this figure is snow and glaciers contribute much more in Indus basin, in this basin, compared to the Brahmaputra basin and Ganga basin. And the reasons are obvious, because the monsoonal precipitation is relatively less into the Indus basin as compared to Ganga and Brahmaputra basin, as well as western disturbance or winter time snowfall is much more higher in Indus basin, because these clouds will move from Indus basin to Ganga basin and Brahmaputra. So as western disturbance move from Indus to Ganga and Brahmaputra, the amounts of precipitation keep on reducing, so their contribution is relatively less. So that has to be understood. So in an overall, you can say Indus basin has 70% of, slightly above 60% for snow and glacier melt. Ganga has around 20% and around 25% in Brahmaputra basin. You can see that it's not only the amount of how much water is coming from snow and glacier, but how it is affecting the food capacity. So if you look into the Pakistan, see you have Indus River which is coming into the Pakistan and entering into the Pakistan, and then they have canal system here, and then water is distributed throughout the Punjab, which is of Pakistan. And then you can see that 96% food production of Pakistan is coming from that canal network only. That means, first of all, you have Indus Basin which is more vulnerable to climate change, and then the food production of Pakistan is much more vulnerable because they produce all their food from Punjab region and very little they produce in Sindh and other regions. So that sense the food production is significantly. And if you look into the India, in Indus Basin it is coming 26% because Punjab and Haryana are producing huge amount of food grain into the India and causing it 66%, and other food grain in India is 36%. So obviously this is very important for us to understand, to stabilize food production in future, because any change in this can significantly affect the food availability to people, and we know that how geopolitical situation now is significantly affecting the distribution of food globally.
Yes, sir.
So let us understand that I was talking about two major components of this. One component is about the seasonal snow and another component is about glaciers. So you can see here that the winter time, almost 1.6 million square kilometer area is covered in Himalaya by seasonal snow, and it is significantly reduced. So it is 85% geographical area of Himalaya is covered by seasonal snow in winter and only 10% in summer. So you can see that 75% of snow of geographical area is melted as we move from winter to spring and spring to summer and autumn. It really gets melted completely. So if you are following any literature, glaciers is highly controversial subject. You know, there's a lot of newspaper articles will come, the TV debates will come about glacier. Older days there was controversy where Himalayan glaciers are retreating or not. But that controversy has significantly gone, and I was the one who constantly arguing that indeed Himalayan glaciers are retreating. And you can see here, this is one photograph which is taken by 1936. This is the Pindari Glacier, which is in Uttarakhand. And you can see how huge this Pindari Glacier was in 1936. And this photograph is taken 2006. Entire this patch over here has completely gone, and glaciers are now confined over the higher reaches. So as of now, glaciers is somewhere like this. So entire patch. So those who argue whether glaciers are retreating or not, some of these photographs are clear example. For that, you can also see that I was constantly going to glaciers, and one of the glaciers was Samudra Tapu Glacier. You can see within 4 years, you can just see this. You keep eye on this particular rock outcrop. You can see this rock outcrop are here, and within 4 years, this entire patch has vanished, and this region is now completely exposed, and the region which was ice is now converted into small lake. So they are indeed melting and melting fast. So there should not be any confusion. There are also satellite images. It's not only happening in Himalaya, it is also happening in other parts of the world. It is Patagonia. You can see how glaciers are significantly cutting off and creating huge iceberg, about which I was talking about. So this is a huge iceberg, depending upon it will keep on moving. So we are really losing a lot of ice into the Himalayas, and you can see here that how glacier area is lost over a couple of decades. You can see per decade it's almost, glacier area loss is 3%, and average retreat is per decade is 144 in. So there is no significant, if you can see Indus, Ganga and Brahmaputra basin, there is no significant change into the loss in glacier area and glacier length. So what are the risks? You know, we know that Himalayan region is warming. It is warming higher than global mean. It is warming higher than other parts of India, and glaciers are retreating. So what impact it will have on society? What impact it will have on various aspects? So some of these aspects we will see that long-term risk of retreating glaciers. So let us look into, first things first is the glacier loss of area or glacier mass loss is not uniform throughout the Himalaya. Some glaciers are retreating faster, some glaciers are retreating slowly. Some glaciers are losing mass in faster rate, some glaciers are retreating mass in slower rate. What it means, its impact on the community will be on different time scales. Some communities can face its burn next decade, some can wait for another couple of decades. But everybody is going to face, but the time frame is different, and that provides opportunity for society and government to prepare communities to face those challenges. So let us look into this. This is this work which is a major work done by Divecha Center for Climate Change to understand how glaciers mass is losing. So what is the mass? The mass is something where glacier every year receives the precipitation in form of snow and it melts. That snow and ice is melt. So the difference between the amount of precipitation and amount of melt is the mass loss. And as glaciers lose more mass, they start retreating. Its volume is reduced, its thickness is reduced, and glaciers are retreating. So that is so you can see here that one of the key observations is low altitude glaciers are losing mass at higher rate than high altitude glaciers. So you can see here is the numerous lakes, say the Bhagirathi basin. These are lower altitude glaciers losing mass which is much higher, and those who are higher reaches have relatively stable mass. So that is first thing to understand. But this is very important message essentially because human habitation in mountains is not at very high altitude. They are at much lower altitude. So what will happen is, as it keeps on changing, and if it is under, as earlier it was shown how under RCP changes, how temperature and precipitation going to change, you can see here that many glaciers, this is in Spiti Basin in Himachal Pradesh, you can see that many glaciers will disappear. And there are some glaciers, and this is by the 2050 and by 2070, you can see. What it means? It means a lot to the communities which are living into the mountains. So this is a small community. Even though community, this is a Kumo village in Spiti Basin, and you can see that this is a small glacier. This is a village, and adjacent to that, this is where this glacier is. So this is a small, so the glacier melts and the water is then taken by a small system, diverted, and they have very high-end agriculture. Essentially because city is completely isolated terrain, so they, whatever food grain they produce, that is a seed grain. That means they have tomato or whatever it may be they produce. It is very high quality, and that is where they get a lot of value for their products. So this is a very prosperous community, and many of them have very, very prosperous lifestyle. We may feel that their houses are made of mud, but that is essentially because of the climatic condition. We may feel that they are putting certain amount of dry thing on that, but that is indeed to protect them for winter time. So these are traditional houses, but they are very prosperous. They make enough money to move from these villages in winter time, come and live in lower altitudes, and they go during summertime. So if this glacier completely vanish in near future, and our estimate suggests by 2050 these glaciers will be, as of now, will be going to vanish. What it means? It means new infrastructure for the government. That means right now the nature is providing water at high altitude. You distribute it through the small canals, bring it down, you don't have to pump, you don't have to invest any money, nothing, it comes into the field. Now it means you have to pump water from the river, bring it up, that means additional investment and additional expenses for the society. And that is only part of water availability. What changes it will make in this region because of the loss of glacier is another ballgame. So that is completely different ballgame. Another issue which is very recently, even last week only I was in the mountains, and you can see that the climate change is really trying mountains very early, as it was shown in earlier presentation that you have warm day in March itself. So what really happens is that the region becomes extremely dry, and because of some or other reason there is a forest fire. So huge amount of forest fires are taking place in March itself. Earlier they used to take in April, May, now it is happening in March. And then there is no precipitation can only come in this region in June or July, so they continue to burn for very long period. And you can see here they are massive. You can see here, and probably you may not be seen but it is very close, because this photograph is taken from 3,000 meter altitude and it is much higher. That means it is taking place around 3,000 to 4,000 meter, and the snow line and the tree line is very high because it is the first glaciated valley into the Himalaya. It is in Parvati Basin, and you can see here that huge amount of black carbon is generated there because of ash, which is generated because of forest fire, and it deposits on the glaciers or seasonal snow. And you know that albedo is significantly reduced because of the ash, and it melts early. And if the seasonal snow melts early, it creates the new issues for the community and the issues related to the mountain spring. So what really happens is now seasonal snow started to melt much early into the mountain, and there is a gap between the departure of seasonal snow, which generally now taking place in March, and by the middle of April most of the seasonal snow is gone, glaciers start melting. So the lower altitude, the moisture is significantly reduced and it is drying up the mountain spring. And you know that as a student of botany and zoology, what is the importance of mountain spring for the mountain overall ecosystem, as well as animals which are living there, vegetation living there. So all these things is now disturbed because of the climate change, and we have to be, this is one, you can see that how albedo is taken. It's only just I wanted to show you that. But there is a solution. That means every time humanity has a problem, there is a solution, but you need to spend additional money for that. And whether how long it will last, we do not know. But it is what is they have done is they try to create the ice stupas, particularly in the some regions of Himalaya, particularly Leh and Ladakh is that. What is the idea of ice stupa is, as you know that because of the numerous and other regions, seasonal snow started to melt early. That means it started to melt in March, February, March. But agriculture, soil is not yet ready, because you cannot have agriculture in February in Leh, Ladakh, or you cannot have in Spiti Valley in February and March. So what you do is, you bring that water and create a sprinkle kind of thing, and because of the difference in altitude, you create a sprinkle, and that sprinkle then freezes. So suppose you have 10 square kilometer area, snow is melting. Now you create this ice stupa, which is in few hundred meters in geographical area. So what it means, it is amount of energy which is received is a very small there, so it melts very slowly. And it lasts for a longer time, and water is available when people are needed, either for agriculture or whether it is for drinking purposes. So now we have almost 26 such stupas are created in Ladakh. This is the latest Government of India publication suggests. and 250 villages is fed, and 7.5 crore liter water conserved, and 50 new sites are identified. But it is not necessary that everywhere this is successful. So there is a huge amount of science needs to go into that to understand. This might be successful in Leh Ladakh, it may not be successful in Sikkim because of the different climatic conditions. So we have to understand all these things. So there is a lot of investigation is being done. But you also have to understand as another issue, probably you would have seen some of the flash flood which is taking place in Uttarakhand, a few years back, 2013, where sudden flash flood has taken place. So this is also a very common phenomenon in mountain, that suddenly you're calmly sitting at beautiful riverside, enjoying your scenery, and suddenly flash flood will come, and so many people have died, mountaineers particularly died because of the flash flood, and there are some reasons for that. And one of the key reasons is formation of glacier lakes. So when glaciers are retreating, they create, they take certain amount of rocks because it will move down, and they create a certain amount of cavity at the bottom of glacier, and when glacier retreat, when this cavity is filled by water, you have a glacier lake. And when the lake is formed, they can burst because of numerous reasons. There are n number of reasons. It can burst, there could be cloud burst. What we have seen in Uttarakhand 2013 is there could be cloud burst, or there could be avalanches, there could be landslide. That also we have seen the landslide in Uttarakhand, and there could be moraine or there could be earthquake. Because of that it can come and it create a devastating flood downstream. So you can see that this is such devastating is a Kedarnath disaster in June 2013. You can see that how this temple is here, and you can see that how that entire region is really vanished because of the extreme flash flood, and that is caused because of either the landslide has taken place that region, and the landslide has blocked the river, it created the temporary dam, and suddenly that dam was collapsed and the flash flood came. So, and there was also heavy rainfall, so rivers were already in very high stage of river was very high, and this additional water created high rock. It changed river Mandakini, which was going from this side, it changed its stream and it went into this side, completely destroying the Kedarnath side. And remember, such lakes are not only one or two into the Himalaya, there are huge. This is a recent work by NRSC suggests that you have huge amount of such lakes are taking place into the Himalaya, and you can say Bias has 96, Chinas 397, Gilgit 1000. So there is a huge amount of Indus Basin has 1000. So there are thousands of such lakes into the Himalayas. So it is not only one or two. So we have to be really careful to understand how this is going to play out in future. Recently you have seen that completely new disaster has taken place into the mountain. There's the Nishiganga Valley disaster last year, where suddenly 2 hydropower plants were completely destroyed, and it can only happen partly because of the climate change. You can see here that this is fall down into the valley, creating new risk for the people. So nobody thought earlier this can actually happen, but since this is a photograph in Spiti Basin, the different valley, but since we go into the mountain, keep on taking photographs, we realize this can also happen in Spiti Valley. And you can see here, this you can see in satellite images, this is the Nishiganga flood in February 2021. You can see here that this crack is similar crack is being developed here. And this entire crack is removed, cause a complete collapse of this entire hanging glaciers had fallen down. And remember, it has fallen down almost, you can see here, this is river, so you can see it has fallen down 1 kilometer down. And once it is fallen down 1 kilometer down, it is the ice volume. We have now at Divecha developed a technique by which we can estimate the volume of ice. So it is 6.86 million cubic meter ice was there, but actually 35 million meters. So the rock, it has taken rock along with that. It has fallen 1 kilometer down, creating slush out of it, and then it has created flash flood, and 2 hydropower plants have completely taken away by this. So this is how it can happen. There could be another disaster in mountain, and that could be because of the avalanches. You can see that this is another thing. You can see, have an eye on this. This is a mountain ridge, but you have, this is protruding out. This, because of the action of wind, this is called cantilever structure. So this is up to this, but actually ice is up to this point. So if you are mountaineer, you are excited to see what is below you. So you will cross this and you go, this is the most fascinating place if people will go further. And there is nothing below it, it will collapse. Moment it collapses, it is destabilizes the snow and creating huge avalanches. And this is now a major risk, and particularly this risk for those who are staying into the mountains, and particularly our army personnel, because they are on all way of the boundary regions, and there's a huge army deployment is there, and every year they experience hundreds of such avalanches. Sometimes there is a casualty, sometimes there is no casualty, but it is a major problem. And as climate change changes, new areas are becoming vulnerable because mountain slopes are becoming unstable, creating new areas. So regions which were not experienced avalanches have also started to experience the avalanches. So if you really look into the risk from cryosphere, there are flash floods from hanging glaciers and landslides, flash flood from glacier lakes, snow avalanches, different glacier mass loss in Indus Basin. We will not go into that in this discussion, but an early melt of snow and vanishing small glaciers, this is the thing. And then I would like to thank you all, but remember that glaciology is the field of young people. So because you require strong legs and strong mind to do the glaciology, so we are delighted if any of you decided to choose glacier as a career, because we really need a fresh mind and fresh body to do the glaciology career. Okay. Thank you.
Thank you for that enlightening talk, sir. Now,
can I ask a question?
Sure, sure.
You mentioned that the top part from the westerlies, the snow is formed, but in Sikkim region it is more because of the rain. And now with global warming and changing monsoon patterns, is the precipitation increasing or is it decreasing in those regions?
So actually this is one still we do not have good data in Sikkim. Particularly there are good rain gauges are there in Sikkim, but we do not have a long-term snow gauges into the system. We are fortunate in Western Himalayas because of what you can say, the geopolitical situation. Since independence there are observatories. So we have last almost 50-60 years data, and some of the publication you see is coming from DRDO side. So they are the ones who are in possession of data. But Sikkim is, we do not have that long-term data to understand how, by using measurements, to understand how precipitation is changing. But remember one thing, that glaciers in Sikkim are also retreating, and because of the peculiar topography of the Sikkim, they have more lakes as compared to the Western Himalayas. It will happen in Western Himalaya after some time. In my own model suggests that after some time there will be more lake in Western Himalaya, particularly in Karakoram region. But right now they are not there. But there are huge lakes. Almost most of the glaciers have a lake at the end, and it is enhancing glacier retreat. So I think now the secondary effect of lake is much more. But you are right that it is also, the mass loss is also significant in Sikkim, but there is no data yet. So I think that is a new challenge. Let us see how we can handle that now.
I also had a question for Srinivasan sir. So you mentioned that in the colder regions with global warming, the crop production is increasing. Is it just the quantitative production, or is it qualitatively also better?
It's quantitative, because one can show that Russia right now, agriculture is tough because it's too cold. As soon as temperature goes up, it becomes better for agriculture. So they'll produce more.
But the produce itself, is it qualitatively better? Like if we are taking...
No, let me say two things. One, the area for agriculture will increase after that area is free of snow, for example. So they'll get more area, and in each area per square meter they'll get more yield. Both.
The yield is not what I'm talking about, so the grain quality I'm asking.
As far as I know, the grain quality is better because the wheat and rice are crops meant for the tropics mainly. Okay? So if the condition becomes more like tropics, they'll benefit.
Good afternoon, sir. Thank you so much for this wonderful presentation. So my question to you is, does the melting of the glaciers can somehow affect the groundwater levels?
Yeah, you are asking very interesting question, because how groundwater, so, you remember groundwater is when the glaciers are retreated, correct? When they retreat, or whether they have a very bed which is very loose material, because it is called moraine. Moraine is the aggregate of loose boulders, soil and other thing, and it is a very loose material. So it has very high permeability and it has very high porosity. Okay, so that region has a lot of capacity to store the water in the form of groundwater. Quick question is whether there will be source of water for that. That means source of water is going to be only precipitation, which is in form of snow there, and if glaciers have gone and that values are exposed. So there was one experiment which I was part of it, particularly in Himachal Pradesh, to understand whether such deglaciated valley, it is called deglaciated, glaciers have gone and it is a deglaciated valley, can be used to enhance the snow. That means snow can remain there for longer period than normal, or can it be used to rejuvenate the springs of them? So that is an important thing, and it looks like that it is feasible if we are able to use, because the snowfall is taken, snowfall is there, no thickness is there, then when it melts, it significantly reduces its albedo because of presence of water. Water has low albedo and snow has high albedo. If somehow able to remove that water quickly and bring them into the bed, which has a capacity to store more water, and then snow can remain free of water, making it albedo relatively better. So some regions, experiments suggest that it is possible to enhance the life of the snowpack and rejuvenate the spring. However, this is because the deglaciated valley at 4,000 meters, so it is not easy for human being to go there and manage it. It is okay to do as a scientific experiment, but it's a completely different ballgame if you want to make it different, which can make the life. But it is an idea, I think, on which we should work, and there are some efforts, but not enough efforts to make it practical. But it is theoretically, yes, and one or two places people are shown it is feasible. Right.
Thank you so much, sir. I have one more question for you.
Yeah. Okay.
So, like in these mountain areas where glacier melting or glacier slides are very much prominent, many architects actually suggest that we shouldn't build dams or any electric power or any hydropower systems over there, because according to them, they can be one of the causes of these landslides and all which are happening over there, because they are very sensitive areas. So what are your views upon it? Like, do you think that we shouldn't build over there? Because in one way, they are helping the inhabitants over there.
See, if you frankly ask me, there is no answer. Okay, I can tell you the difficulties. Because society and politicians are going to take decisions based upon their perception how society should be changing in future. Let us take, for example, this Nishiganga valley, where the flash flood had taken place and 2 hydropower plants were completely washed. Where was that? It is just 7 kilometers away from Nanda Devi Glacier Snout. Nanda Devi is a biosphere, that means you cannot construct any hydropower dam, anything, is completely banned, but which is within the Nanda Devi biosphere. Then that region has experienced 1990 major Chamoli earthquake. The epicenter of that earthquake is in Trishul Peak, which is a part of this Nishiganga Valley. We have sent a lot of army on the border of China. So we have, now there was 1 road, now we have to make 4 lane road. So there is a huge construction is going on there. So, but still we have hydropower station. And you saw the implication of that, how it has affected, poor laborers have gone, some engineers have gone. But villagers, which were smarter, they never came down. They were sitting up there. They have not affected. So what I'm saying to you is, obvious answer is no, because of this thing. But that does not mean that you are not going to have development. At least because not all decisions taken based upon the scientific inputs which is going there. So some sort of development is going to take place. But if you happen to go to the mountains and talk to the people, nobody wants hydropower station, as far as people are concerned. Essentially because there are issues. So I will give you another example. If you happen to travel from Simla towards the Spiti Valley, you will come across the Satluj River, where 3 kilometers, 4 kilometers of Satluj River, there is no water. It's completely dry. There is a dam, water is behind, water is diverted for hydropower, put it here, 3 kilometers, no water. Then again there is a dam, there is a hydropower station, water is diverted, another 3 kilometers, no water. So what it means? How ecology is going to change? It is all along, at the moment Satluj enters into the India from Tibet, till it goes to the Bhakra-Nangar, there will be another 10-15 dams like this. And there are dry patches in between, and all that is leading towards the landslide. The roads are washed, so you spend crores and crores of rupees rebuilding road every year. So, but still it is there. What I'm saying to you is, it is very politically sensitive issue to address it. But if you look into the people, they will say, no sir, what is the problem? Because the moment they have a hydropower station and they build it, there is so much vibration. Houses were collapsed because of the vibration into the mountains. So there are issues, What I'm saying to you is, society is going to take decision on the basis of what is their best for them. And sometimes we need to, interest of local people are not necessarily all the time accounted for the larger interest of the society.
Thank you so much, sir. Thank you so much for all your ideas, and we'll surely try to apply your ideas in our real life and bring a better change. Thank you.
Thank you. Thank you very much.
Any more questions, girls? Okay, so we have questions from online forums also. First question is from Gagana N. How drastically would climate change affect lower organisms such as insects? How long would it take for climate change to destroy the life on Earth completely if it is possible?
I really don't. Graph which is shown by Professor Srinivasan is talking about there are, as of now, how much energy is coming from sun and how much we are now emitting and going back into the space. Based upon that, there are three possible solutions, and one of the solutions is ice ages. So we can go back to that, but we don't know. The mathematical modeling is not yet clear under what condition it will go. There's any.
Yeah, it takes a long time. The next ice age was supposed to come 50,000 years from now, not in the next 100, 200 years, 50,000 years. Now, because of human action, it may be delayed by a few thousand years, maybe. Because the long-term changes will go on. Earth orbit will change, all that will happen. So human being is a small perturbation in the long term. Okay?
Sir, lastly, I have a question. Recently, we have introduced, as Sir told, government electric vehicles policies, solar generation, everything the government policies they are introducing. As you told, COP treaties also, they are trying to reduce a global climate change. How far do you think it is effective in the current scenario, sir? Sir, recently there's a government policies where they have introduced electric vehicles. Recently there's a government policies where they have introduced electric vehicles and trying to reduce fossil fuel emissions and all. And also there's, as you told, international treaties also where we are planning to reduce the climate change, global warming, everything. Recently, given the current programs or strategies, how much do you think it is effective to culminate this?
You must remember that last year, 68 million petrol and diesel vehicles were sold, 68 million, and 1 million electric vehicles were sold. So see the ratio. We are a long way to go. So the transition from petrol diesel vehicle to electric vehicle will take 50 years. Okay? So most of you will see the change, but it is very important to make the change rapidly. But we don't know what will happen or not. There are some people who are saying it will, for example, the very interesting photograph is there showing in the city of New York, change from horse-drawn carriage to petrol vehicles in 10 years. Okay? So some places it can happen rapidly, but globally it will take 30, 40 years. The question is whether it is fast enough to prevent global warming. I'm not sure, unless you do it more rapidly. So the latest report came out 2 days back, warned that the change is going on. Solar is coming, wind is coming, but it's not going fast enough. That is the issue. So all of you will watch in the next 5 years, every 5 years there will be a debate in the United Nations on this issue, and every 5 years there will be warning given, and people will have to tighten their things, do the change. Change will happen, but the question is how rapidly. That's the issue.
But yes, if you can add something, we should not be disheartened because change is slow. Every baby step matters. So all of us who have capacity to reduce our carbon footprint, we should do it because it matters. Because individual action matters, and if individual we can do collectively as a society, it will matter. So we should not dishearten because it is slow, but we should definitely do whatever we can do in our life.
Thank you so much, sir. I'm sure we all will take away this as a point and try to reduce our carbon footprint from today. Thank you for clearing all our doubts. Now I request Ms. Bhavya ma'am to take over.
afternoon all. I hope you enjoyed the session. Thank you is such a word that cannot be seen or touched. It must be felt by heart. I feel honored and privileged to get the opportunity to propose this vote of thanks on this occasion. I would like to thank the honorable speakers, Professor J. Srinivasan, distinguished scientist, founder chairman, Divecha Center for Climate Change IASC, and Dr. Anil V. Kulkarni, distinguished scientist, Divecha Center for Climate Change IASC, for such an interesting session. Thank you, sir. If time is money, then you have spent millions on us today. I, on behalf of Department of Zoology, convey deep regards and hearty thanks to Shri K. Jairaj, Managing Trustee MLAC, and Dr. Shashikala A., Principal MLAC, for giving us an opportunity to organize this session. I would like to thank our beloved HOD, Professor Aruna H.K. Madam, for the constant help and guidance that has radiated a source of energy for us today, and we have organized such a session. Thank you, ma'am. I am very thankful to all the organizing members of our department who are sitting here, engaging the session. Thank you, all of you. I'm pleased to thank Saumitri Ranganathan Madam for constantly guiding us and supporting us throughout the presentation. Thank you so much, Madam. An event like this dimension cannot happen overnight. The wheels start rolling months in advance. We have been fortunate enough to be backed by a team that is very motivated and committed. I cannot thank anyone enough for their involvement they have done, and they have shown the willingness and they have expressed to complete this task. Thank you so much, and I think that we'll take this session as a motivation and we'll inculcate all these things from now on. Thank you so much. I just welcome Dr. Shashikala KB Madam, Smita Ma'am, and Hema to just give this mementos to the guests. Girls' feedback link has been put in the group and on Zoom also. Please give your valuable feedback. Thank you.